motion for constant gravitational acceleration. Already in the chapter of motion we have studied equations of motion, but here the body is falling under the effect of gravity, or if we throw a body vertically upward, then these three equations are modified according to this. These three equations are written in this: v is equal to u plus gt, h is equal to ut plus half gt square, v square is equal to u square plus 2gh. G is considered as positive if the body is falling vertically downward under the effect of gravity, and G is considered as negative if we throw a body vertically up. If we write these three equations for falling body, then we have to take plus sign here, and if the body is throwing up vertically up, then in place of plus sign we have to use minus sign. And once again, this gravitational force is a centripetal force, means a body which is uh, experiencing gravitational force, it always falls towards the center. The angle which is made between earth and this falling body is always 90 degree, and you know that this tangent always makes 90 degree from the radius, and if you release a body, it strikes on the surface, and the angle between the earth surface and this is always 90 degree. So that's why the direction of this acceleration is towards the center, and the acceleration is called centripetal acceleration, and the force is centripetal force. Mass and weight. Mass is a quantity which is contained by a matter. How much quantity is contained by a matter is called its mass, and it does not vary place to place. If a body is kept over the moon, over the earth, its mass will be constant always. Its unit is kilogram. Here the mass can be measured by this, and the weight is measured by this spring balance. Mass is measured by this simple physical balance. So these are the two instruments which are used for measuring mass and weight. Weight is a quantity which depends on the mass of a body along with gravitational acceleration. The formula of weight is mg. M is the mass and g is gravitational acceleration. We know that gravitational acceleration depends on the mass of the astronomical body like earth and radius of the astronomical body like our earth. That's why gravitational acceleration varies, and weight depends on the gravitational acceleration. That's why weight of a body should also vary place to place. Its value becomes zero at the center of earth. If we kept a body at the center of the earth, the weight of a body becomes zero, and weight of a body on the surface of moon will be different to the weight of a body on the surface of the earth. Weight of an object on the moon. Here in this picture we are seeing mass of the body is same in all these four astronomical body: earth, moon, Jupiter, sun. Mass is same, but weight of the body is different. It depends on the mass of the body and radius of the body. In this four figure we are seeing sun is having mass which is very large. That's why the weight of the body is maximum out of all these four, and the weight of the same body is the least. So weight varies place to place. According to this equation, this is Newton's law of gravitational equation, W is equal to capital G mm upon R square. We can calculate the weight of a body on the surface of earth or on the surface of moon, anywhere. Here we want to calculate weight of an object on the surface of moon, then we can calculate by this formula. We have to know mass of the moon, radius of the moon, so we can calculate the weight of this body on the surface of the moon. Thrust and pressure. Thrust is nothing but a force which is acting perpendicularly on the surface like this. If we apply perpendicular force on the body, on the surface, then it is called thrust. because it is a force, that's why its unit is Newton. Here we are studying thrust because thrust only makes pressure. Here in this figure we are using a needle. This needle is making thrust and the pointed end, this needle is having pointed end. By making pointed end we can make a great pressure. Then the pressure depends on thrust. Along with thrust it depends on area also. Thrust per unit area, thrust which is acting on the surface per unit its area is called pressure. Pressure is equal to thrust upon area. By reducing area we can produce a great pressure. So here in this needle we are using this reducing area and increasing the value of pressure. Its SI unit is Pascal, the name of a famous scientist. The same force acting on a smaller area exerts a larger pressure and smaller pressure on a larger area. So by using this we make pointed tip needle, sharp knife, sharp edges in knife, and foundation of a building should be very wide. So these are the applications of pressure. If we want to reduce pressure, then we decrease area, and if you want to decrease pressure, we increase area. Pressure is inversely proportional to area. Pressure in fluid also experiencing pressure on the surface, on the bottom, and this walls of container in which it is kept due to weight. Pressure is exerted by the body due to its weight, because this fluid means liquid and gas. All liquids and gases are fluids, and if we take a liquid which is kept inside this beaker, then the wall of beaker experiencing force, the base of this beaker also experiencing this pressure, and the pressure is increasing in this direction. If we go from top to bottom, then the value of liquid pressure, fluid pressure increases. So the jet which is coming from the bottom of this vessel, this is the strongest jet, means the speed of the liquid which is coming out from the hole should be very, very large. With maximum velocity it is coming out, because here the liquid which is producing pressure on this surface, it should be maximum. So this is the weakest jet, this is the strongest jet. The pressure is increasing in this direction. Buoyancy is the property present in every fluid. Every fluid is having this property. If a body is immersed in a liquid like water, then you know that if we immerse this body inside this, the weight of this body will be decreased due to a force which is called buoyant force. So the property is called buoyancy. When a body is immersed in a fluid completely, then the body experiencing buoyant force or upthrust force, due to it loses its weight, and we feel the lighter, we feel body becomes lighter. If you take a stone, very heavy stone, and immersed completely inside the water, then you feel that stone becomes lighter. Now you pull out, then the weight of this becomes so large, the weight of a body increases. So if you keep a body inside the water, then it loses its weight due to this property. The name of the property is buoyancy. Here in this figure it is clear. Why objects float or sink when placed on a surface of water? All the bodies when kept inside the water, then some bodies float, some bodies sinks it depends on the value of buoyant force which is experienced by that body. If the value of buoyant force is greater than its weight, then body floats, because the direction of buoyant force is always in upward direction. And if the weight of the body is more than the buoyant force, then it sinks. A small nail sinks, whereas a big wood log floats, because in case of nail the value of weight is more than the buoyant force, that's why needle sinks, whereas in case of big wooden log the buoyant force is more than the weight, that's why a wooden log sinks. Archimedes principle. This principle is based on the buoyant force. This is proposed by a famous mathematician scientist Archimedes. When a body is immersed in a fluid, it experiences an upward force which is called buoyant force, that is equal to the weight of the liquid displaced by it. If we take a body in air, by doing a simple activity, we can verify Archimedes principle. In this activity, we are using one spring balance, a metal ball, a beaker which is completely filled with water, a weighing machine. What we do initially, we take the weight of this metal ball in air. This is its real weight, because buoyant force due to air is negligible, so it is considered as real weight. Now if we dip this ball inside a beaker, completely immersed inside this beaker, then some water will be rushed out due to buoyant force. The ball is taking the space of water, that's why some water is coming out, and this ball is taking the space of water. Now we see the reading of this spring balance. We see the reading is 50 gram weight, almost 10 gram weight is lost. Loss in weight is 10 gram. It is also called upthrust force, which is applied by the water over this ball. The value of upthrust force you can say is 10 gram weight. Now what we take now, we remove this beaker and remove this spring balance also. The water which is rushed out from the beaker, it is collected here, and the reading of this weighing machine is almost 12.72, and the loss in weight was 10 gram weight, and here the water which is collected inside this plate is almost 12.71. According to this activity, we can say that the loss in weight or buoyant force is exactly equal to the weight of the liquid displaced by the body when it is immersed completely inside the water. By this activity, simple activity, or you can say an experiment, we can verify Archimedes principle. Now, one more interesting phenomena, which is relative density. Density is the property of every substance which will not vary. It is almost constant. The density of water is 1000 kilogram per meter cube. If it is pure water, no impurity is there, then its density is always 1000 kilogram per meter cube or 1 gram per centimeter cube. The density of any substance is almost invariant, constant. That's why we can take the relation between the density of other substance along with the density of water. We take water is an ideal substance because it is a substance which is easily available, and we want to explain the phenomena of flotation, and a body floats over the water only when its density is less than the density of water. Due to this, we have made a special term here, relative density. In this term, we take the ratio of two densities. One
one substance should always be water, then what is its definition? Relative density of a substance is defined as the ratio of density of the substance to the density of water. Relative density is equal to density of substance upon density of water. If you want to find out the density of copper, which is 8.94, then you first of all put the value of density of copper here and upon density of water. Like this you can find the density of copper. Because the density of copper is more than 1, that's why it sinks. A substance which has relative density more than 1, then substance will sink. If the relative density is less than 1, like cork, alcohol, then the substance will float over water. And if the relative density is just equal to 1, then body just floats like water. Water has relative density 1. Water floats over water. If we mix some water over this, then you cannot say it is floating or it is sinking. I mix some water, then where this water will go? You have no answer. You cannot say it is floating or it is sinking because the density is same. Relative density is 1. So according to this, you can give a law of flotation. You can make a law of flotation. If the relative density is greater than 1, then body sinks. Relative density is less than 1, then body floats. Relative density is equal to 1, then body just float. In case of ice, you can say ice just float over the surface of water. So that's all for this presentation. Thank you very much.